Hello, everyone. Today, we're diving into a fascinating challenge in the world of artificial intelligence, the black box problem. Artificial intelligence is all around us, helping machines learn and make decisions, often performing complex tasks like humans. At its core, AI takes in data, processes it, and then provides an output or a decision. But sometimes how AI reaches its conclusions remains a mystery, leading to what we call the black box problem. This problem often arises with advanced AI models, especially deep learning neural networks. These networks have many hidden layers where millions of calculations happen simultaneously, making them incredibly powerful. The sheer number of parameters and nonlinear relationships makes it nearly impossible for a human to trace every step of a decision. So even the AI's creators might not fully grasp why it made a specific prediction or decision. The why behind an AI's output is often missing, leaving us without critical insights. One major concern is bias. If the AI learns from biased data, it can make unfair or discriminatory decisions. Without understanding the black box, it's hard to identify and correct these biases effectively. In critical fields like healthcare, a doctor needs to understand why an AI suggests a particular diagnosis before trusting it. Similarly, a bank customer denied a loan by an AI deserves to know the reasons behind that rejection. In autonomous systems, like self-driving cars, understanding AI decisions is crucial for safety and debugging potential failures. Even in legal systems, AI-driven decisions regarding sentencing or parole raise serious ethical questions if opaque. For developers, debugging an AI black box is incredibly difficult. You can't fix what you don't understand. Regulations are also emerging that demand transparency from AI systems, especially those impacting human lives. This is where explainable AI, or XAI, comes into play. It's an entire field dedicated to opening up these black boxes. The goal of XAI is to make AI models more transparent and their decisions understandable to humans. When we understand AI, we can trust it more, fostering better human-AI collaboration. XAI also helps developers identify and fix errors, biases, and vulnerabilities in their models. It helps us ensure fairness and ethical decision-making, which is paramount in critical applications. Some AI models are inherently interpretable, like simple decision trees or rule-based systems, where the logic is clear. But for complex black box models, XAI aims to provide an explanation without necessarily simplifying the original model itself. XAI techniques can offer local explanations, clarifying why a specific decision was made for a particular input. They can also provide global explanations, helping us understand the overall behavior and patterns learned by the model. One popular local interpretability method is LIME, which approximates the black box's decision for a single instance using a simpler, interpretable model. Another powerful technique is SHAP, which assigns an importance value to each input feature, explaining its contribution to the final prediction. These techniques often produce feature importance scores, telling us which parts of the input data were most influential. Some methods extract simplified rules from complex models, giving us a more human-readable logic. We can also use sensitivity analysis to see how an AI's output changes when we tweak individual input features. Counterfactual explanations suggest the smallest change to an input that would lead to a different desired outcome, like if you earned 500 more, your loan would be approved. For image-based AI, visualizing activations or saliency maps can show which parts of an image the AI focused on. XAI is a rapidly evolving field, with researchers constantly developing new and better ways to peer into AI's inner workings. However, there's often a trade-off. Highly accurate, complex models can be harder to interpret, and vice versa. Finding the right balance between complexity and interpretability is a key challenge in AI development. The future of AI will increasingly depend on our ability to make these powerful systems understandable and trustworthy. By embracing XAI, we move towards a world where AI isn't just intelligent, but also accountable and transparent. Understanding the black box problem helps us build better, safer, and more ethical AI for everyone.